Hello, everyone. Let's see. Today we're at the beginning of chapter 2. Hopefully, you survived chapter 1 okay. I know it was a little weird. Chapter 1, really small piece, just an introduction. Uh, we bounce around a lot at the beginning of this course with ideas, and then after about 5 chapters, we kind of draw them all back together. So each chapter is kind of independent of the other ones at the beginning. This chapter 2 is just on displays. It's basically how to take data and display them. So we're going to talk about specific displays in the next section. So right now we're just going to talk about what things might look like. We're kind of looking at histograms. This is a typical histogram right here. So we're just talking about like words to describe a display. And once you put them and what does it look like? How do you describe them? So the idea of today's lesson is just to describe these displays. So what you see here is what's called a uniform or rectangular distribution. Notice they're not all exactly equal. One of the things is nothing's ever going to be perfect in this class. It's going to be roughly uniform, roughly rectangular, but the idea is we have basically a rectangle there, so it's roughly uniform. We are going to spend a big, gigantic amount of time in this class on what's called the normal curve. Normally, I would tell you some stories about the normal curve if this were a class and why you don't want to ever ask a teacher to curve a test. If we have time in class, ask that question. Why don't you want someone to curve? Why don't we as a student want a teacher to curve a test? And I'll try to explain why, because curving a test uses what's called a normal curve, which is this picture here. So our entire course is actually based on the normal curve, okay? So this is what a normal curve looks like. Nice little picture of it. It's got some properties that I'll tell you about right now. It's just the basic shape is what you're looking for. The properties here is there's a single peak. That peak is the mean, the median, and the mode. We're going to talk more about those words later on. If you don't know what those are, don't worry about it. I'm sure some of you probably do. It has a line of symmetry right smack in the middle. Okay. Get rid of this for the next part. It's got points of inflection. Here and here, a calculus term. If you took calculus, maybe you remember what a point of inflection is. Changes from concave up to concave down. Not super important in this class at all, although they do occur at pretty important spots. But the term inflection point doesn't really matter. And here's maybe the most important piece of information about the curve for right now. It's roughly 2/3 of the data, 2/3 of the area underneath the normal curve fall within one standard deviation of the mean. We're going to talk more about standard deviation as we go. So right now, just a quick introduction. I won't really describe what it is yet, but I will, don't worry. So little terminology, you see the little Greek letter mu there hiding right there. That's the letter we use for mean. And then you see the lowercase sigma there. This is the terminology we use for standard deviation. Okay, so what you see here on my curve is +1 standard deviation, -1 standard deviation. So we're going to the right 1 standard deviation, to the left 1 standard deviation. And in a normal curve, that area right there, 1 standard deviation on either side is roughly 2/3 of the area of the normal curve. We'll figure out later on exactly what area it is, but for now, 66 2/3%, even 67% is probably an okay thing to say. Notice that almost all of the data occurs within 3 standard deviations of the mean, hardly anything further out than that. So that's a normal curve. Our whole entire course is based on that one curve. We're going to study it in depth later on. We're going to do a little bit in chapter 2, section 2.4, but then later in the course, we'll really study the normal curve a lot. This is what's called a standard normal curve here. And simply a standard normal curve is one that has a mean of 0 and a standard deviation of 1. It's a specific type of normal curve that has a mean of 0 and a standard deviation of 1. It's the basis of our entire course. We're going to study this one in depth. Notice on the other one, I even put it 0s and 1s, but those means could be anything. But we'll chat more about that as we go. Not all curves are normal, so some get what are called skewed. Okay, this graph is called skewed left. Sometimes people want to call it skewed right. I can see the logic to both of them, but if there's like this little extra tail on the left-hand side, it's called skewed left. And in a skewed left distribution, The mean would be to the left of the median. And we'll talk about median a little bit more. We got a skewed right curve, which is this next one right there, which is just the tail the other way. Typically, what causes a distribution to be skewed is this idea of minimum or maximum. So let's say if we looked at housing prices, if we tried to draw a graph of housing prices, typically that's going to be skewed right. And the reason it's going to be skewed right is because there's no real maximum. I know there is a maximum, it's the highest price house, but you're going to have a lot of houses, between, let's say in Mountain View, Los Altos, between $1 and $2 million, a whole bunch. There'll be some less, some a little bit more, but then you're going to have some way out here, 15 million, 20 million, 25 million. So housing prices are typically skewed right. Like athlete salaries are typically skewed right. Got a whole bunch of people in the middle, but you got the ones way out there that are making a lot more money than anyone else. So skewed left, skewed right. We're going to ask in the homework tonight, you'll see some questions that do you think it's skewed left or skewed right? Unfortunately, sometimes you need some outside knowledge for those problems, so do the best you can. If you have trouble with them, we'll fix them up in class tomorrow. Okay. All right, just some terminology that you may or may not know. Median, I use that term. Median is the number that divides the data equally. I should put when in order. And I'll show you an example in just a second. The quartiles are three numbers. There's a first quartile, a second quartile, and a third quartile. Those are the numbers that divide the data into fourths. The second quartile is the median. And so sometimes we call them lower quartile, median, upper quartile. Sometimes we call them quartile 1, quartile 2, quartile 3. So let me scroll to the end here and just show you how to do one. So if I have these numbers like 1, I'm just going to make up some numbers here, 5, 6, 7, not too many. 1, 2, 3, 4, 5, 6, 7, 8. We'll start with a nice easy one, 9 numbers. So if you go 1, 2, 3, 4, 1, 2, 3, 4, this becomes your median. It's the number that's right smack in the middle. Now, if I want the quartiles, so let me keep going on that one. That was with an even amount of numbers. If there's an odd amount of numbers, oops, sorry about that. Let's get out of there. If there's an odd amount of numbers, like 1, I'll just do a couple of 4, an even amount of numbers. Now there's no exact middle, right? There's 2 and there's 2. So the median is actually the average of those two numbers. So 4 and 7 is 11. So the median would be 5.5. So a little bit easier. If there's an odd amount of numbers, it's the middle number. There will be a data point. If there's an even amount of numbers, it won't be. It'll be the average of those two. And then quartiles, you do the same thing. To find the quartiles, you do the same thing. So we come back up here. The first quartile is just the middle of those 4 numbers, right? So the 6 was the median. So we go 1, 1, 4, 5. So we would want the average again of the 1 and the 4, which is 2.5. That would be the first quartile. And over here, the average of the 8 and the 9 would be the third quartile. Okay. On this particular one, let me put in a couple more terms. 1, 3, 4, 4, 6, 8, 9, 11. 1, 2, 3, 4, 5, 6, 7, 8. So in this case, we go 1, 3, 4, 4, 6, 8, 9, 11. So notice the median is the 5. When I do that, now to find the quartiles, I find the quartile of 1, 3, 4, 4, 6, 8, 9, 1. Okay, so you're like splitting it in half with those. Just like up here, though, that 6 does not get counted. The 6 does not get counted on either side. We're going to show you how to find these things on a calculator later on, but for now, I want you to do it by hand. Quick reference on that. Our calculator can do a lot of things, but I'm not going to allow you to use the calculator to do all these things until you show me you know exactly what those terms mean. So in other words, you have to do it without the calculator first, and then I'll show you later on how to do things in the calculator. It's going to be pretty common in this class for us to learn a little bit first. And then the last one here, erase that, is just called bimodal, just because it has 2 peaks. Those peaks don't have to be the same size. You could have a bimodal that looks like that, still has 2 peaks. So these are just words you want to use. The next and last thing I have for you is just a bunch of important words. They're going to ask you to describe a distribution. when they ask you to describe, you want to refer to the shape, the center, and the spread. So anytime I ever say describe this distribution, it means shape, center, and spread. So I'm going to talk about what words you can use to talk about that. And then one other things, we're going to say others. We'll ask to serve. Those are just like anything else that you see that might be important to point out. And I'll have a couple of those words here in just a second. All right. So the shape are all the words I just gave you. Bimodal, skewed left, skewed right, normal, uniform, things like that. Okay. That's the shape. That's usually the easiest one. If there are clusters, you should mention that as an other. In other words, if you got a whole bunch of numbers in one place and a whole bunch of numbers in the other place, you might want to say, oh, there's a whole bunch of numbers clustered around 10 to 12. There's a whole bunch of numbers clustered around 20 to 30. You want to say that. So that's like in others. If there are gaps, you'd want to say that also. So like if there's clusters and gaps, which is common. If you have clusters, often you have a gap, but sometimes you don't have the clusters. But there's a big, gigantic gap. Let's say they're test scores. And say, yeah, there was no test score between 70 and 80. You might want to mention that. Okay. If there are outliers, you might want to mention this. And for right now, we're just going to use this term suspected outliers. We're going to talk more about outliers later in this chapter. Right now, it's just if you think it looks like an outlier, all an outlier is something that looks out of whack. Just like doesn't fit the rest of the stuff, you'd want to say that. Okay. And that's just kind of your opinion at this point. So center, there are three ways to refer to center. Really just two though. Mean and median. A lot of times people talk about mode. We're not going to talk about mode because it's useless, to be honest with you. So if you say center, you just got to tell me which center. So you'd say, hey, the mean is about 50. The median is about 50. Don't say the center is 50 because then I don't know which one you're talking about. Sometimes we want to talk about mean. Sometimes we want to talk about median. It's easier to find the median because all you got to do is count. The mean, you got to take out your calculator, add up all the numbers. So it's typically easier to find the median. Typically, we use the median if we have skewness because let's look at this one. It's easier. If some guy out here had a $10 million, or let's go $100 million house, a lot of money, what would happen is the average would go way out here. So it would be out of whack. So if you see housing prices ever in the newspaper, it's almost always median they talk about because the median is not affected by the outliers. Okay, we'll talk about that more also as we go. Next is spread. Spread, you can talk about middle 50% is the easiest thing to talk about. You could also do standard deviation, but you don't have a way to find standard deviation right now. So when I say middle 50%, for example, in this data, here's what I would say. I would say the median is 6, this data here, and the middle 50% is between 2.5 and 8.5. So if you find the quartiles, all three of the quartiles, you can do center and spread like that. You can just say the median is whatever, and the middle 50% is between blank and blank. Okay. And the last little word I have up there is variability. We'll talk more about variability. Variability is just another measure of spread. But for us right now, if someone says describe, here's what you'd say. Something like roughly normal, median, 40, and middle, 50% between 30 and 45. It kind of does a nice little job of describing your shape. We'll actually show you how to draw a box of whisker pots and things like that to help with that. So that's it for section 2.1. Let me know if you have questions before we go over it in class. Have a nice afternoon, evening, whatever it might be when you're watching this video.